Hey guys, welcome back. I hope you're having a great day. Today we're going to be going over lesson 5-8 in geometry. Now the first thing we encounter in this lesson is a 45, 45, 90 degree special right triangle. And an interesting theorem arises with that. So as you can see on the screen, we have a 90, 45, 45 degree triangle. And so let's go ahead and take a look at that. So because we know that that it's a right triangle, so it's going to be 90 degrees is one angle. We know that another angle is 45 degrees. We know that the remaining angle is going to be 45 degrees as well. Now based upon this, we're being told that the two legs of this special right triangle are equal. They're the same thing. And subsequently, the hypotenuse is going to be x by the square root of 2 if each leg is equal to x. Now I'm going to explain that using the Pythagorean theorem. So we have one leg squared plus another leg squared equals the hypotenuse squared. Now here we have x as one of our legs and x as the other leg. So we know that the length of BC is equal to the length of CA. So that means that the Pythagorean theorem here really pretty much turns into a squared plus a squared is equal to c squared. Now, when we take a look at this, this kind of simplifies down into 2a squared equals c squared. And that's because whenever you have one number plus itself, it's going to, like 2 plus 2 equals 4, that's going to be the same as that number multiplied by 2. So 2 plus 2 equals 4, 2 times 2 is equal to 4 as well. So we're just using that with variables here. Now it's important to remember that it's not 2a squared, but 2 multiplied by a squared. So we're going to go ahead and put that into brackets. Now, you can probably tell the next step is going to take the square root of both sides. And because if you take the square root of any number squared, it's going to equal itself. So we're going to have a multiplied by the square root of 2 equals c. And that relates back to x. We can have x squared plus x squared is going to equal some c squared. Then you're going to have 2 multiplied by x squared equals c squared. And then you're going to come up with x by the square root of 2 as the hypotenuse. A second theorem is introduced about another special type of a right triangle. And it's the 30, 60, 90 right triangle. Now, this states that one of the legs is going to have, the smaller one of the legs is going to have a length s. It says that the hypotenuse is going to have a length of 2s, and it's going to say that the height, or the larger leg of the right triangle, is going to be s by the square root of 3. Now this can be easily shown through an equilateral equal angular triangle. So I'm going to kind of roughly draw that here. Now BC bisects this base side, right? So we know that that this segment is equal to this segment, right? But we also know that all the sides of this large equilateral triangle are congruent. So we know that this side is congruent to this side. Because half of this side is s, the full side is going to be s plus s, which is equal to 2s. So that kind of gives us this side as 2s. So that explains why that is. But just given the given conditions, we can use the Pythagorean theorem to kind of prove this. Now we know s is one of the legs, so we're going to have s squared plus. Now, really what I want to show is, because I just showed why this is 2s and this is s, so I'm going to show why this is s to the square root of, or by the square root of 3. So we're going to show that that piece, this second leg is x, is going to equal 2s squared. And this is going to be x squared. So we know that s squared plus x squared is equal to 2s squared this time, which is 4s squared. Now, because we have s squared units over here and s squared here, we can simply subtract s squared from both sides. That gives us x squared equals 3s squared. Take the square roots, you get x equals s by the square root of 3. And that is how you figure that. So down here we have an example of one of the 90, 45, 45 triangles. So we know that the hypotenuse is x multiplied by the square root of 3, right? Because if we come up here, we have the hypotenuse is x by the square root of 2. Sorry. So this is 3 by the square root of 2, and this is x, right? So because this is the hypotenuse, we're going to go ahead and say that 3 by the square root of 2 is equal to what? Well, it's equal to x, so one of these leg lengths multiplied by the square root of 2. So we're going to go ahead and we're trying to find x, so it's going to be x times the square root of 2. Now when we divide by the square root of 2 to get x on its own, we get this setup, okay? 3 multiplied by the square root of 2 over the square root of 3. Now what happens when you multiply? You don't want this square root of 3 in the denominator. So we're going to multiply by the square root of 3 over the square root of 3. Now, you can do this because any number divided by itself is 1, okay? And because when you multiply any number by 1, it doesn't change, we're simply kind of changing the number, but we're keeping it the same. So we're going to get x equals, now the square root of 3 multiplied by the square root of 3 is the square root of 9, and then we're going to get the square root of 2 multiplied by the square root of 3, which is going to be 3 by the square root of 6. Now the square root of 9 is obviously this 3, so 3 by the square root of 6 over 3 equals x. 3 divided by 3 is 1, so we're going to get the square root of 6 equals x. The final example we're going to be dealing with is I forgot to draw this in, but it's a right triangle with 30 degrees and 60 degrees. I apologize. So we know that 9 is the shorter leg, x is the height, or the larger leg, and y is the hypotenuse. So because y is the hypotenuse, we know that y equals 2 times the smaller side, which is 9. So y equals 18. Now we know x is equal to the smaller side, which is 9, multiplied by the square root of 3. So we know that x is equal to 9 multiplied by the square root of 3. So that's that. And we have both of these lengths we were trying to find. If you have any questions or suggestions or anything else, go ahead and let me know. So thanks for watching, and I'll see you next time.